Hello, my name is Kevin Sigwart. I'm a principal consultant at OneSpatial. During this video, we will be demonstrating how the OneSpatial commercial off-the-shelf tools can help with managing facility spatial and non-spatial data. Traditionally, facility data has been created using CAD software and managed through database systems like Archibus and asset management systems like IBM's Tririga and Maximo. However, facility managers have been wanting to have better visualization software, indoor navigation, and have the ability to perform advanced geospatial analytics. These high-end analytics and visualization tools can only be achieved by having a Geographic Information System or a GIS. Without the proper tools, migrating the facility data into a GIS can be very tedious, expensive, time-consuming manual project. In order to have accurate analytical results, the data needs to be at a certain level of quality. Then once the data is migrated into a GIS system, the data needs to be kept in sync with the CAD and asset management systems. The OneIntegrate tools by OneSpatial can help make life easier by automating the migration and synchronization of your spatial and non-spatial systems. Also, the tools will give you the status report of the quality of your data at any given point in time. At OneSpatial, we define three aspects for having the spatial advantage: data validation, data integration, and data enhancement. The OneIntegrate product provides a rules engine to define the data quality standard your organization and your industry requires to ensure proper analytics and accounting reliability. The rules-based engine can automate the quality assurance and quality control of spatial and non-spatial data. This reduces the time-consuming and subjectivity that occurs when doing a manual QA/QC process. By using this rules-based approach, you can know the quality of your data at any given point in time. The OneIntegrate product can integrate data sets within your GIS or can connect across the enterprise into a variety of other spatial and non-spatial data sources. This enables rules to be written to validate two separate enterprise systems. Take, for example, you have an Esri geodatabase and a Tririga database. OneIntegrate product can read both data sets into its cache and validate that both systems are in sync, minimizing orphan records and inconsistent data across the enterprise. Also, many geospatial systems are siloed off. For example, in very large organizations with many campuses, each campus may have their own GIS team managing the data with variations of the corporate data schema. The OneIntegrate product can connect into each database and roll them into one centrally managed database, keeping track of any changes that have been occurring to the data. Lastly, once you have identified data quality issues, the tool provides the ability to write actions to autocorrect the data. These actions can even be configured to generate a set of proposals to propose to the user what and how the data should be updated. These data correction actions are so flexible that they can be written to correct data, create new data, conflate existing data, or perform change detection. The first demonstration will be using OneIntegrate for ArcGIS to validate and correct geospatial facilities data. The rules will validate the geospatial data for proper attribution and geometries. We find that importing CAD data into GIS systems often cause many issues inside of a GIS. This can be the result of the CAD data not being properly aligned, or from the CAD data being a schematic representation instead of a geographic representation of the data. In the past, fixing these issues in the data was a time-intensive manual process. However, OneIntegrate provides the ability to locate where these issues are occurring and then can auto-correct the data. Let's switch to ArcGIS Pro and take a look. Alright, so now we are inside of ArcGIS Pro and we're going to be running the OneIntegrate for ArcGIS. Now, it's important to note that we can also be running OneIntegrate for ArcGIS inside of ArcMap, or we could be running, if we're using the server edition, we can be running it within the web or on a mobile device. So in this case, we're looking at a campus, and the campus has a variety of buildings, floors, and rooms. And this is three-dimensional data, so what we're looking at here is we're looking at the first floor, but I can flip up and change to whichever floor I want to look at any given time. So we can go all the way up to the third floor or back down to the first floor. Now inside my map I have a variety of layers. I have my building footprint layer, and we can see where these building footprints are located. Inside of a building footprint, it tells us the identifier for the building itself. Now this is going to be important when we're going to be matching to other layers in the data set. We also have the number of floors. So one of the rules we're going to check later is we're going to make sure that the number of floors match the actual number of floors that are on top of the building itself. With that, let's go ahead and turn on the floors. And now we can take a look at my floor data set. Here we have that building identifier, so it should match to the corresponding building. We have the floor number. Then the next layer we want to look at is my building interior spaces. So when I select one of my building interior spaces, we can see that there is the building name, so we can join it back to the building table. We have my floor identifier, which tells me which floor this particular room is on. And we have my full space name, which has that information about the building, the floor, and the space ID. We also should have information about the area of the room itself, which tells us the number of square footage that this particular room contains. The last data set we have is my building interior space point. And this one should match to the underlying building room. So if I select one of my points here, we'll see that this particular space point has that same unique identifier. So we have that unique identifier space ID, which should corresponding to the room that it's underneath. And we should have a corresponding floor area. So now what I want to do is I want to validate to make sure that my data is actually correct. So instead of just running this on each individual floor, we're going to run it on the entire campus. So I'm going to remove the query that queries out each individual floor and just bring it validated on the entire data set. So let's go ahead and zoom out to my entire campus. And let's go ahead and turn on my rules. So I'm going to go to my OneIntegrate for ArcGIS tab to see the rules that are associated with my particular data set. And what I'm going to do first is I'm going to run my essential geometry checks. We provide the essential geometry checks out of the box as a set of starter rules. And these are going to search for typical issues that occur when doing geospatial editing, or even when you're taking CAD data and bringing it over to GIS. So I'm going to go ahead and run these set of rules, and we're going to extract those features out into our data cache and validate them. In running this rule set, we were able to validate 2,800 features across 8 rules in 8 seconds. One of the many advantages of the OneIntegrate product is the ability to do complex validations across large data sets. This is possible because the OneIntegrate for ArcGIS product extracts the features into the OneIntegrate data cache, which is an object-oriented database designed to handle large, complex feature-to-feature comparisons extremely quickly. In this case, we only validated 2,800 features. However, the rules engine is designed to be able to validate hundreds of thousands or even millions of features extremely quickly. So let's go ahead and take a look at the results. What we'll notice is next to each one of these rules, we have a green, a yellow, and if there was a really bad issue, a red. And this defines how well we map to each individual rule. So green means it's good. There's 0 nonconformances. Places where it's orange is where we have some. So we have 11 features that are duplicates. And then if there was a red, that's where we have significant issues. We also are reporting inside of our results window which issue has, the rule that has a nonconformance, the feature set that's occurring on, and the ID of that individual feature. And if we select the particular item, it highlights it on the map and then zooms to that particular issue. Inside my contents window, we also have a layer for each individual rule that has nonconformances. So if I wanted to share this with maybe my editors, maybe I'm the QA/QC person and I want to share these with the editing person, I can right click on one of these layers, go to data, and export out those features so that those editors can now have access to those where those issues are occurring, whether that's in a file geodatabase or in a shapefile itself. So let's just take a look at one of my issues, and that's going to be my kickbacks to start. And we could see that we have a kickback here. I can use my bookmark to zoom into that kickback. And what we'll notice is that right now we can't actually see the kickback because of there's many features on top of each individual feature, so it's making it difficult because we're looking at multiple different floors. So what we're going to do is let's subset out my interior space data set to just look at the first floor. So we're going to build a definition query, and we will just look at the floor number that is 1. And now we can actually see the feature and where the kickback's occurring. Also notice that we're identifying the exact location of where this kickback is occurring. This is one of the advantages, or another advantage of using the One Integrate product, is that we don't only just tell you that there's an issue with the feature itself, we can identify where the issue is actually occurring. And this is important if you have to do this throughout an entire large data set many times. If you had to go through and search your feature for 15-20 minutes, finding where this issue is actually occurring, it could take a lot of time. So in this case, you know exactly where it's at, and then you can go in and fix those issues as needed. So let's now take a look at my duplicate features. So I'm going to turn on that layer. And in the meantime, let's also remove my definition query and move over to those duplicate features. Oops. So here we have 4 notifications on these features saying that there is a duplicate feature. So if I select one of my features here, we're going to notice that 4 features were selected. There's likely 4 floors for our building interior spaces. So let's take a look at each of these interior spaces. And what we'll see is these 2 features here, the Q3WREST7 and Q2WREST7 are occupying the same space. So if you look over here while I toggle these 2 data sets, you'll see that these are occupying the same space. But what you'll notice is that these 2 data sets are actually on different floors. So even though they're a duplicate feature, they're not really duplicate because they're representing 2 different floors. So what we want to do is we want to update the rules slightly to not look for where we have duplicate features on different floors and only look for duplicate features that are occurring on the same floor. So we have another rule where it's checking for duplicate rooms. And in this case, we have 1 duplicate room. So let's take a look at that. So when we're toggling through, we'll see that we have 3 that are duplicate features, but we'll notice that in this case we have floor 3, floor 2, and floor 3. So we have 2 rooms that are on the 3rd floor that are duplicate features. My next set of rules I'm going to run are some custom rules that we ran to do some floor checks and some building interior space checks. So let's go ahead and turn on both of these and go ahead and run them. And these are custom rules based off of the business rules that my organization has set up. We should not have null values for my floor ID. Every floor should have a matching building ID. Every floor that has a building ID, the geometry of the floor should actually be contained within the geometry itself. And then we do that where we check to see, well, give me the count of all the floors that are intersecting my particular building to make sure that the building floor count is correct. And then we also have checks for my building interior spaces, making sure we don't have floor areas that are null, making sure my floor area points match my floor area polygons. So let's go ahead and take a look at the results here. We have 3 issues. So let's first take a look at the issues we have with the floor area being null. So we have here, we have a floor area that is null. So let's take a look at that particular feature. And I can see here that my floor area is indeed null. We also have problems where the floor areas don't match. So this is where the floor area of the point, this interior space point, doesn't match the floor area of the interior space polygon. So let's go to this other bookmark here. And what we'll see here is, let's actually select my point first. This point for room 01E125 has a floor area of 5, but if I look at the actual building for that, the actual polygon I should say, for 01E125, the floor area should actually be 5.78. So we have a mismatch here. And then the last rule we have is where our floor counts do not match our buildings. So let's move back out. Right, so, and let's just, for this case, let's just take a look at building floors and buildings. Now what you'll notice is that wherever we have a notification, in most of these cases, this is where there's no floors actually showing up. So if I select this building here, we have, it's saying that there should be 1 floor, but there's 0 floors actually there. But if I select this guy here, we have 1 floor. And if I take a look at the building itself, the building says there should be only 1 floor. And then if we look at one of these other guys here, this one says there should be 3 floors. If I select my building floor now, there's actually 3 features here, 3 floors. That's why that was not flagged as a nonconformance. What I'd like to do next is switch over to our OneIntegrate for ArcGIS rule authoring environment to show you how you can actually write these rules to identify the nonconformances. So the first rule I'm going to show you is what we call a quick rule. And this is where we can make sure that maybe a geometry is of a certain length or of a certain area. We can do attribution checks. We can make sure that a particular space has a specific attribute value. Or we can do spatial relationships. So in this case, what I'm saying is that my space point must be within, so my interior space point must be within at least 1 building interior space. So object of class building interior space point must be within at least one building interior space. What happens if I want to extend this rule to not just say that the point has to be within a polygon, but saying that not only does it have to be within a building interior space, but it has to be inside of building interior space that has the same identifier. So what we could do is we can write what we call a long rule. So I'm going to go ahead and convert my quick rule to a long rule. All right. Now notice we have our long rule, and we're saying the same thing. Building interior space point. For every building interior space point, there should be at least one building interior space where the geometry of that point is within the building. Then all we need to do is add a sibling. So we're creating an AND statement. And we're going to write a condition, and we're going to say that my attribute value of my building interior point, the space ID, should also be equal to my building interior space ID. And you can make this as complex or as granular as you like based off the business needs that you have. So for example, we can have something as simple as checking to make sure that my floor area is not null, to that other check where we're checking to see that the floor is within a building, right? So in this case, we're checking not just that the floor is within the building, but we're making sure that it's within 90% of that building. And we can even extend it to get the count of the number of floors that are inside that building. So you can see that there's a lot of flexibility in the way that you can write these rules. And what we're going to do next is, now that we've found these issues, we're actually going to start to auto-correct those issues. So I'm going to switch to my Enhancements tab now. And the first thing we're going to do is, actually, let's go ahead and run both sets of these. We're going to fix my geometric errors. So just like we had that out-of-the-box set of geometric checks, we also have an out-of-the-box set of geometric fix-ups. This is where we can remove our duplicate vertices, smooth out those kickbacks and spikes. But in this case, I have a remove duplicate rooms. So instead of removing any duplicate feature, I'm only going to remove if two rooms are within the same floor. We'll remove one of those rooms. And then we're also going to fix those service points where they don't match the interior space or if the values are null. So let's go ahead and take a look at these results now. So if I zoom to some of these problematic areas, so let's move to where that kickback was occurring. So just like before, we have to toggle to just look at the floor. So we're going to go ahead and build my definition query. Now notice we no longer have that kickback there anymore. We can also go to where we had those duplicate rooms. Now remember, this was the place where there was that duplicate room. If I select that area, you notice now we only have those two features, and those are on different rooms. So we actually corrected that issue. Then we could take a look at where we had that floor area that was null. I believe it was this feature right here. And we can now see that my floor area has been updated based off of the underlying features. So if I take a look at this one, you can see that it's been updated based off that underlying feature. Then we could go to see where we had that other one where there was a mismatch, not just a null. And if I select this guy here, it should be 5.78, which it is, which matches the corresponding room. So we used OneIntegrate for ArcGIS to identify where we had non-conformance issues, and then we used also OneIntegrate for ArcGIS to auto-correct those issues. The next demonstration, we're going to shift gears. Instead of just focusing on your GIS, we're going to focus on geospatial and non-geospatial system integration. As mentioned earlier, the OneIntegrate product can connect into more than just Esri geodatabases. It can read your geodatabase, CAD data, and connect directly into business databases such as Oracle, Postgres, and SQL Server. With this functionality, the OneIntegrate tool can write business rules to validate your geospatial and non-spatial systems. For example, OneIntegrate can validate that a room object in the TRIRIGA database has the correct square footage based on the area of the GIS room geometry. So let's go ahead and switch to our OneIntegrate product and demonstrate that capability. Alright, so now we are inside my OneIntegrate product. The OneIntegrate product is a server-based solution which allows you to connect to your data sources, write rules against those data sources, correct the issues with the data, and then write them back to the original data source. So there's four main components of the OneIntegrate product. There's the data store, rules, actions, and sessions. The data store is where we connect to our different data sources. So in this case, I'm connecting to my campus file geodatabase. If I go to my input details, I can upload my file geodatabase, or I can connect to other data sets, such as Bentley MicroStation design datasets, CSV files, the Esri Enterprise Geodatabase, Esri shapefiles, map info data, or even connect directly into other enterprise database systems such as Microsoft SQL Server's native spatial type, the Oracle native spatial type, and PostGIS. Once I make the connection to the database table, it then automatically loads in the entire schema for that data set. So we have a building. Inside my building, I have all the attribution, and I can even, if I'm doing schema mapping, I can update how the data is portrayed inside my rules engine. So then we can also take a look at where we're connecting directly to an Oracle table. So in this case, I'm connecting to my Oracle table, and in my Oracle table, I may have my TRIRIGA data. So I'm going to connect as my TRIRIGA user using the connection information. Then I have access to all those tables that's inside that database. So for example, I have an employee table and a room space table. I then can write rules against that particular schema. So when I come over here, you'll see that I'm writing the rules to that employee and the building databases. And then I can also write actions to maybe correct those issues. And then I have my sessions, which is where I tie together connecting to the data, bringing the data into the cache, running the validation checks, running actions to correct it when I find a nonconformance, and then I can write the data back to the data source using a update commit. So in this particular session queue, we're going to validate my TRIRIGA database with my GIS database. So I need to bring in both of those different data sources. So we're bringing in my Oracle table, which has that employee information table, and my room space information table. And just to take a look at what the employee table looks like, we can view that employee table. In my employee table, I have a location ID, and for that location ID, I have an individual person. Now if I come back to my session, we can look at my campus data and view the map where this is actual GIS data. And then in my map, I have building data sets. I also have a building floor and I have my building interior spaces. Right? If I select one of these building interior space polygons, we have information about that building interior space, including the space ID. Right? So what I want to do now is I want to check my employee table and make sure there's a corresponding space ID inside my GIS database. I want to make sure that there's not some sort of orphan record between the two different data sets. So what we're going to do is we are going to run my first validation check. Now notice here we have some pauses inside of my session queue. This is very useful if you're doing if you're trying to come up and start writing the rules as an interactive interface. You can run the rule, pause it, see the results, and then at any point rewind back and rerun that rule once you make an update or an edit change. And all this is being stored inside my session queue. So anything that happens is being saved, and you could step and look at every single stage of those updates. So let's go ahead and run my validation check. We found inside doing this validation check three people inside the TRIRIGA database that didn't have a corresponding space. And just to show you what that rule looks like, let's take a look at that rule. So we're looking at my employee table and looking at for each employee there should be exactly one building interior space where the location equals the space ID. So we go back to my session queue. We see that there are 3 employees that don't, and let's just take a quick look at those employees. And we can see that these are the 3 objects that do not have a matching location inside the GIS table. Now the question is do these locations really not exist, or does this person really not have an actual room, or is there an issue with my location identifier? So what I want to do is, instead of using the location identifier to find a matching record inside the GIS, I'm going to use information about the building, the office number, the floor, and the wing to put those together to see if there's an actual matching feature. So what I did is I actually found one record where there was actually a mismatch in the location IDs, but where the building information, the room, the wing, and the floor were actually the same. So let's take a look at that. So for this particular person, Steve, the building information was the same, the wings were the same, but the location and the space ID were slightly different. We could see here that the space ID was 01 and the location was 0A1. So that's why there was this mismatch. There was one had an A in it and the other one didn't. So what I want to do now is, since I know that this is a mismatch, I want to update my database so that it has the correct matching corresponding ID. So then we run an action to actually correct that particular issue. And if I take a quick look at what my action's doing, we're looking at my building interior space where the building information, the wing, the floor, notice how I'm converting the floor to an integer to get rid of leading zeros, and the office number are the same. And then if that's the case, then we're going to update my data set, where we're going to update my location information so the location is equal to the space ID. Now that we've fixed that, we can rerun my validation check to see how well we're now matching. Now notice that since we updated that record, we still have 2 nonconformances, but that's one less nonconformance that we had that we're not having now. And if I go view my results, we could see that at least for this particular person, for Margaret, her office number is 0. So it's likely that there's no 0 record and there's some sort of issue with this particular table. So that's where we need to go and contact Margaret, find out which office she's actually in, and update this data set manually. The next thing I want to look at is I want to look at my room information table inside my Tririga database. And in this case, we can take a quick look and just show you what the room table looks like. We have a space ID, and for that space ID, we have an area, the square footage of that particular space. Now what I want to make sure is, I want to make sure that this square footage is correct. So to do so, we're going to look at the GIS geometry, calculate the area of that geometry, and make sure that those square feet are actually the same. So if we come take a look at this particular rule here, we're looking at my room space objects, my building interior space objects, where those space IDs are the same, and we're going to say the area of my room space table record is equal to the actual geometry, the area of the geometry of the feature itself in the map. Now when I come back to my session, we'll notice that we have 20 nonconformances. So there's 20 records inside my table where the space area is not actually equal to the actual geometry inside my GIS dataset. And we could take a look at those results, and we can see there's some cases where maybe this is not an issue with the actual mismatching. Maybe there's some sort of rounding issue. So what I want to do instead is I want to find out if the area inside of my table is within a specific tolerance of the actual area of the geometry. So let's take a look at the rule again here. Now in this case, what I'm doing is I'm getting whether the space IDs are equal, but instead of just seeing if the area is equal to the other area, I'm doing a tolerance of 1 square foot. So I'm making sure that the space table record is within 1 square foot of the actual area. And when I update that rule, I now find that I only have 15 nonconformances where they don't conform to that particular rule. Now once I find these issues and correct these issues, I then need to write the data back to the data source. This is all happening within inside of our data cache, which is why you can take a look at the stage of all of these runs at any particular point. So what I'm going to do now is I'm going to run a commit task, and I'm going to commit my data back to my Oracle database table. And then when I run my session, it's going to write that data back to that database table. Now it's important to note that we are doing a commit, so it's going to be doing adds, deletes, and updates. So if a feature has a attribute that's been updated or a geometry that's been updated, it's only going to update what it needs to update. It's not going to delete the feature and re-add the feature. So just to recap, we were able to connect into not just a geodatabase, we were able to connect into a geodatabase and an asset management data set and validate that there's no orphan records and those different systems are actually in sync. The next demonstration is tackling an issue that many GIS professionals wrestle with. CAD data typically comes with a .wld file or world file because the actual CAD data is not in projected space. It's in paper space, meaning the coordinates are in relation to the CAD drawing and not necessarily the real world. The world file provides reference points so that the data can be visualized in a GIS. The problem is that this may only contain 2 reference points. Then when we bring in the data, everything ends up being skewed. The larger the represented data, the more likely the data will be skewed. Using OneIntegrate, we can generate shift vectors to show the amount of shifting that needs to occur across the entire CAD drawing, and then shift all the features according to those shift vectors. So let's show you how you can use OneIntegrate to generate the shift vectors and then shift the data according to those vectors. Alright, so before we actually do the shifting inside of OneIntegrate, I just want to show you the data that we have and the results, and then we'll go and show you how that we actually were able to do all this. So in my data set, I have my building interior spaces. These are my room data. Then I have some inputted CAD data that I want to bring in to my data set. Find out what's been changed and bring that in. So I'm going to turn on that CAD data. Now what we're going to find is that when I'm looking at my CAD data, we're going to see that the data is not actually correctly aligned. And it's not just the polygon, the line data is also not aligned also. And this occurs throughout the entire data set. We can even take a look at my staircase, see how that staircase is not actually aligned, and so forth. So what we first need to do before we can do any sort of shifting is we got to find out, we have to build our shift vectors, and to build our shift vectors we have to find two corresponding features in these data sets. Now if I look at my CAD data and my building interior space data, and we'll just go ahead and do a quick identifier. Right. There's no sort of corresponding information inside these data sets that helps me determine which one is my CAD data set and which one is my interior space. So the only thing that we can use is the spatial area. Now, if you may have an Archibus table or something like that, you can use that to help you say that this room needs to be shifted to this room. But since we don't have that, what we're going to do is we're going to use the area of and the geometry to find out which rooms I can shift. So that's where we now have where we found rooms that have a similar configuration. So if we look here, we can see that these guys are all similar, so we were able to bring those over. Now that I have two features that I know that can be joined, I then can build those shift vectors using OneIntegrate. So now when we zoom in, we'll see that we generate our shift vectors on how we want to shift our data. Now that once we have those shift vectors throughout the entire data set, we then can perform our shifting to shift everything. So notice after we shift everything, now everything is in line, and it's not just the polygons that are right where the shift vectors are actually occurring. But if I go to my staircase, we can actually see that my staircase is actually now aligned as opposed to what it was before. So let's now switch into our OneIntegrate product to show you how you can do the shifting itself. Alright, so now we're inside my OneIntegrate product where we're going to be doing the data shifting. There's two main data sources that we want to look at here. We want to look at my campus data, my building interior spaces, and for my CAD data, we have my polygon and my polyline data set. So let's take a look at the map and see how these two actually align. And we'll just look at my CAD data and my GIS data. And when I zoom in here, we'll see that there are definitely some alignment issues going on where things are not properly aligned. So as I said originally when we were looking at inside of ArcMap, we need to first find where we have matching features. And before I even do any sort of matching, I want to write a rule finding out, well, how many features do we actually have a match for. So let's go ahead and fire this off where I'm checking my matching rooms, and I find that I have 90% of rooms that match using my geometry check. So let's go ahead and take a quick look at that geometry check and show you what we're looking at here. So I'm looking at my CAD data. I'm making sure I'm only getting the rooms in the CAD data. And then I'm finding all of the GIS interior spaces where we intersect and we make up 95% of the area of the polygon. And I'm looking at it from comparing the CAD data to the GIS data, and also the GIS data to the CAD data. Now, in doing this, we found that we had a 90% conformance, so we only had 23 features that didn't match. So this should be enough to build my shift vectors, but if I notice any sort of issues with the way my shift vectors are being generated, I can always go and manually add a couple more features to match together. So the next thing is that now that we know that we have a 90% conformance, let's build out the matching rooms. So now I'm going to generate my matching rooms, and when I build out my matching rooms, we could take a quick look at those rooms. And these are all the rooms that we found a match for. And just to come back, I can say after I do the matching rooms, I can then write rules to check to see how we performed. And now when I go from looking at my CAD, I have 90% of my CAD features being represented and 91% of my GIS rooms being represented. Now that I have those matching features, we can then start to do the actions to build out my shift vectors. So now I built my shift vectors, and we can take a look at those actual shift vectors that are being generated. And looking at the map, we can see where we have my shift vectors being generated to align my data. Now that we have those shift vectors generated, we then can apply our shifting algorithm to shift not just the rooms, but also the lines themselves. Once we shift the lines and the rooms, we then want to just build the topology to snap everything together that are within a specific tolerance to make sure that we still are maintaining proper topology and proper connectivity. Now that the topology has been built, let's take a look now at those results. And we can now see that everything is aligned correctly inside my map itself, as opposed to what it was like before, where it wasn't aligned correctly. Once I finish, I then can write that data back out to my source so that I update those features. So in that last demonstration, we showed you how you can take the CAD data that is slightly off alignment and shift it using the one integrated product to do the shift vectors. And with that, that concludes our demonstration. Today we showed you 3 demonstrations. We showed you the ability to do data validation of attribution and geometries. We showed you how you can validate across enterprise systems like a Tririga asset management system and your geospatial system. And then we also showed how when you bring in CAD data to your GIS system, a lot of times it's not aligned correctly, and we can apply shifting algorithms to shift the data to be all properly aligned. And with that, I'd like to thank you for watching this video. If you have any questions, feel free to contact myself at kevin.sigwart@onespatial.com or contact the company at onespatial.com. Thank you very much and have a great day.